Hello, my name is Brian Zill, and I'm a member of the Network Research Group here at Microsoft Research. And today I'm going to be talking briefly about our Hawaii project. First, I'm going to present a quick overview of what the Hawaii project and platform is about. Then, to make this a little bit more concrete, I'm going to give an illustrative example of what an application using the Hawaii services would look like. Then I'm going to go a little bit more into the details about our university engagement effort and the platform services and equipment that we've been providing to participating universities. And then I'm going to sort of dive in more deeply into the different APIs and services that student programmers would use to access these services in their own applications. And I'll summarize everything with a list of resources. So now I'm going to give you a brief overview of the Hawaii project. The idea of our platform is we want to allow student developers in university courses where they might have a sort of class project or other development effort to produce a mobile client cloud-enabled application. And we want to make it easy for students to do this without having to do a lot of the boilerplate themselves. So these sort of applications can get quite complex in the number of back-end services that an application might want to use. And if you had to develop each one of these yourself, it would get to be quite onerous. And so we're trying to provide as many of the more general purpose services that mobile client apps might want from the cloud to these applications, and make it much easier for the students to concentrate on whatever their specific application is all about and not have to worry so much about the general boilerplate stuff. So what do I mean by a cloud-enabled mobile application? What I mean by that is an application that runs on a client, usually a mobile client like a handheld or a laptop that is moving around in the world and might need, for whatever reason, some service that's available in the cloud. And the kinds of things that these, especially for smartphone applications, might need are things like depositories of data, or things that are not readily available on the phone itself, or also phones are very resource limited in how much computation and also how much storage they can have. And so being able to access those things via the cloud is very important to such applications. Also, just to use the cloud services, oftentimes there are other services you need, such as a way to authenticate yourself to the cloud service. And that in itself might require the use of another service. Plus, there are things like being able to determine where your physical location is. This is very important for a wide range of mobile applications. And there's several other services that I'll get to later that are also useful in these sorts of environments. So to make this all more concrete, I'm going to give a quick example of what such a mobile cloud-enabled application might look like. And the example I'm going to give is a Find My Phone application. So the general scenario is that the user loses their phone. And then they log into the Find My Phone website, and they issue a request for the phone to report back where it is. And then the user can then view the phone's location on a map and go, oh yeah, I left it over there. So that's the general concept of this application. While this seems like a fairly simple application, there's actually quite a bit of infrastructure involved in making this whole thing work. So you have the user at their home PC and the user's phone, and you have the Find My Phone website, and you have these 4 services that will be used by either the phone or the website in the completion of this application. So hopefully before the user loses their phone, they would go to the website, download a little program onto their phone, and then use that to register the phone with the website. And then at some later time, when the phone gets lost and washes up on a desert island somewhere, the user can come back to the website, authenticate themselves as the person who was there before and the owner of the phone. And the website can then use the notification service to send a notification to the phone that it should report back in. The phone, when it gets this notification, will go to the location service to find out where it is, and then tell the Find My Phone website what that location was. The user can then get that location back from the website and optionally view its actual location in the world using a mapping service like Bing Maps. So while that all seemed very straightforward when played out, there, as you saw, were 4 different services that we used, and other applications might need to use different services or other components. So now I'm going to mention what we've been doing this year for our university engagement efforts with, for our spring semester we had 3 schools involved, and we have several more schools involved for our fall semester. And for each of these semesters in 2010, we're basing everything around a Windows Mobile 6.5 client. That will change for next year, which I'll get into in a minute. But for 2010, we're providing phones, tools, SDKs, sample code. Our phone is an HTC Pure. We also provide Windows Azure access and access to Windows Live ID, which can provide authentication services. Hawaii Location Service and API. That provides the application with its current longitude and latitude. And I'll get into that more in a minute. Bing Maps provides map imagery for any place on the globe, and also provides conversion between, say, an address and its lat long and vice versa. And finally, there's a notification service that we wrote that provides sort of background notifications to running applications of events that happen elsewhere, which is useful in many different applications. So starting in the spring, we're going to switch to using the new Windows Phone 7 as our client. And Windows Phone 7 has a location and notification service APIs built into the platform. So that's even easier to use than having us provide them. But we have other services we're also planning to add in addition to the other ones that were on the previous slide. We're currently working on providing a rendezvous service, which is so 2 different clients that have some criteria for finding each other or other clients can use the rendezvous server to put them in contact with one another. A relay service, which provides for NAT traversal or other mobile tracking sort of. A problem with mobile clients is they don't generally have fixed IP addresses, and so you need some way for them to be able to find, or actually when you're doing peer-to-peer, to exchange things between the 2, because you can't usually create a direct connection between the 2 clients. Also text-to-speech, speech-to-text, that's pretty straightforward. And another thing we're looking at is a geotag video catalog. This would store videos based on where they were shot and allow people to look up video at a particular location. So now, going back to what we're currently providing, this is the phone that we've been using these last 2 semesters. It's a Windows Mobile 6.5 phone. It has a touch screen, fairly high resolution. It has a 3G radio that's compatible with AT&T's network here in the US. It has built-in Wi-Fi for when you don't have 3G. It has Bluetooth. It has a GPS, which is very useful, a camera, and a bunch of other things like an accelerometer, a light sensor, even an FM radio. The development environment we provide is Visual Studio 2008. And we also encourage people to do their programming in the .NET Compact Framework. This allows them to use C#, which is a nice object-oriented programming environment. And there are a number of SDKs for the Windows mobile device itself that make it very easy to program things to the phone. And another nice thing about this particular programming environment, it's very similar to programming .NET for the desktop. So if you have any previous background using .NET or C# coding for the desktop applications, you can very easily carry it over into programming for the mobile device. One of the services, probably the most popular service we've seen so far, is the location API. This is both an API that runs on the phone, and it talks to a backend service, and it provides the location of the phone essentially. And it does this using either GPS or radio location. So if you are outside or someplace where you have good radio receiver connectivity to the GPS satellites and can get a GPS lock, it will tell you what your GPS coordinates are. But if you don't, if you're inside somewhere and are only able to receive signals from Wi-Fi access points, what it can do is it can take the BSS IDs of those Wi-Fi access points, send them off to the service in the cloud, and it will figure out where it's seen those Wi-Fi access points before and tell you what their geolocation is. And that will let you know where you are based off what Wi-Fi access points you can hear. And in the event that you don't have even Wi-Fi access points but can hear a cell tower, it can go even wider in its area of estimation, but still at least get you close to where your actual location is. Also, the Big Maps API, as I mentioned earlier, provides both street maps and imagery. It can translate between location representations. It has several different APIs depending upon whether you want to call it from the browser or from web services. And I'll skip the demo of the map. We also provide Windows Azure accounts. Now, Azure is a cloud service provider platform, which allows people to develop their own services in the cloud. It also provides a certain amount of database storage. So you can use it both to do computation in the sense of a web service or website, or you can use it as essentially a SQL server. And the programming environment, again, looks very similar to that of a website. And if you use ASP.NET, it's also .NET coding in C# and can use the same development environment and tools that you use to program for the client. So as I mentioned, the development tools are pretty much the same as you'd use on the client. And there are, instead of creating an application project, you create a project to hold the Azure configuration, and essentially what you're coding is an ASP.NET website, and then you can upload that to Azure, and it's sort of like having your own web server, except it's in the cloud rather than having to host it yourself. Windows Live ID provides an authentication service. This essentially allows a website to know that the same person has come back to it that had done something there before. So it essentially gives a unique ID for everybody who signs in. And if you return to the website will be given that same unique ID for you. And so the website programmer can use this to store something per user and retrieve it later. And there's an authentication SDK that makes it very easy to use this to, again, in C# code or ASP.NET code, to use this in your own website. And we also have written our own notification service, and we provide the service. We host it ourselves, but we provide example code for how you would call it. The purpose of this is that since mobile devices usually don't have a fixed IP address, it can change at any time, It's nice to be able to have a place that the mobile device can go to and say, tell me when this thing happens, whatever this thing might be. And then your application or service running elsewhere can send the notification through the notification service down to the client, and the client will then wake up or realize that you're trying to notify it of something. This can be done for a wide number of different channels, so you can listen for different types of events that you're interested in being notified of, and at a later date, the channel can be signaled to wake up or notify those clients. Finally, you might have noticed that there seem to be a large number of these SDKs and development tools involved in this project. So to make it easier for people to use all this stuff, rather than having to go and individually download all of the 10 to 15 different things, we're producing a developer's VM, which is a virtual machine that student developers can run, that gives them a development environment that has all these SDKs already installed and configured and set up so that they can just immediately dive in to start coding, and you don't have to worry about getting everything set up and configured yourself. We also provide a forum for people to ask questions of either ourselves or each other, and that's up on the Microsoft Research Community Server. It's a private forum just to keep the spam down. So if you want to join in, please create an account for yourself on the community server. Send us an email at the address there, hiforum@microsoft.com, and tell us your account name, and we'll add your account name to the access list for the forum. And also, to allow people to easily try out each other's applications, we've created an application depot, which is essentially a list of applications that students have submitted for download by other students. And we just put the URLs in a list and provide a little application depot application that runs on the phone. And you can bring up that application on the phone, look through the list of apps, and decide to download any of them, and it'll auto-install the application on your phone, and you can try out the other students' applications. So the general place to get information about the Hawaii Project is a Hawaii Project website. It's the upper URL right there. If you look underneath the information for students and about development, there will be another pointer to this subpage here, which has more additional information and example code for how to use all this stuff. And all the other links that I've talked about and SDKs and pointers to them are all available on this website. So this is probably the most important part of this talk is to remember that website. And that's pretty much all I'm going to talk about today. So thank you very much for watching, and we hope to see you as part of the Hawaii Project.